So some of these problems sound like word problems. So for example, it says a quantity is initially 5,000. Quantity y is initially 5,000, and it decreases at a rate of 35 per day. What you're about to say is fine, but it doesn't really matter. But it's number 2837. But it's an example of this kind of problem. So quantity y is initially 5,000, and it decreases at a rate of 35 per day. Let's just make up some stuff. Let's say it's $5,000 for some used car, and it depreciates at $35 per day. Is that cool? Just to put some more physical reality on top of this. The minute you drive it off the lot, it's depreciated. So they want you to come up with an equation for this. What's nice about this statement is then we realize what that number 5,000 is the y-intercept. Because initially means at time 0, at 0 days. Right before you drive it off the lot. Right before you even step inside, just in case when you touched it. About to step inside, it was $5,000. This beautiful little used car, right? This lemon, that you don't know yet. So the y-intercept is 0, 5,000. So B is 5,000. And then what does this represent?
The
Slope.
Yeah, slope is rate of change. So that word rate is a huge clue that probably is the slope. Such a huge clue. So slope is 35. So can somebody tell me what the equation is? Sure, y equals mx plus b. So y equals
35x plus 5,000.
35x plus 5,000. Now, be careful. I'm not being careful myself. Decreases at a rate of $35. Negative 35. I like it. Good. I just realized I'm like, wait, you don't drive it off the lot and it appreciates the value. That'd be awesome. We sell this back to you for a profit of $8,000. No, don't happen. It's like your textbooks, right? So look out for, so learn from my own little mistake there. Look out for those words. It tells you, is the slope positive, is the slope negative? All right, so there's a big chunk of problems just like this, but they're telling you all this immediately useful information. The y-intercept, the slope. So putting this equation together is easy. Let it be easy. Okay. So just a little preview. That's the end of chapter 3, right there. So we got the quiz coming up, but we'll also be getting into chapter 4. And how many guys remember doing systems of equations?
I remember the name.
You remember the name? Okay, I like it. So remind me, when I graph, if I graph this equation, up here, what does that line mean? Tell me something about the line and how it relates to the equation. When I draw through those, what is that? What am I doing?
It's showing you that has the same slope.
So like this point right there on the line, what's true about it?
It has the same slope.
It's a solution to the equation. That's the connection between the visual and the equation itself, right? So every single point that line goes through works in that equation. So what if I had another equation? That's crazy. What if I had this equation? You could do it. Sure. So what's that guy's y-intercept? 2. And what's the slope?
Minus 1.
So I go
Down 1.
down 1, over 1. So what's true about all the purple points? They all work in the purple equation. Is there an answer that works in both equations? And where would that be? Where they meet. I mean, it almost makes too much sense to believe. If I draw a line, all the points on that line work in that equation. I have another line, I draw it, all the points on that line work. So is there any points that work in both? Yes. Well, there'll always be a point that works in both. Because my two lines could be, oh shit. Then that would be no solution. It makes almost too much sense to believe. So we'll start with the graphical way to solve systems. And when we say a system of equations, I mean more than one equation. It's a system of equations. I can have several equations. But how many unknowns do I have? 2. So how many equations do I have? 2. And with 2 equations for 2 unknowns, I got an answer. What's the answer, by the way?
1 and 2.
1, 1. 2 times 1 minus 1 is 1. Negative 1 plus 2 is 1. So 1 works in both. I like it. So if I had 3 variables, x plus y plus z equals 7, how many equations total would I need?
3.
That's crazy. That's crazy. If there are 2 things I don't know, I need 2 pieces of information. 3 things I don't know, 3 pieces of information. So if I was a homicide detective, what am I trying to gather? Information. Because what is the whole purpose? What am I trying? I have a lot of shit I don't know. So the more shit I don't know, the more information I got to gather. Right? I love this connection. I'm not saying that math is all about solving murders, but there's a connection between gathering information. How much information do you need, given how many things do you not know? All right. So that was a little preview. That's plenty for today, I think. Really, really early. That's fine with me, because I got a lot of work. Yes, ma'am. Go ahead. What's the point of this relation?